We're going to evaluate the integral of cosine of the natural log of x. First note that cosine of natural log of x is not the same as cosine of x times the natural log of x. What we have on the right is the product of the two functions. What we have on the left is the composition of the two functions. So we'll be integrating the composition, not the product. We'll be using a technique called integration by parts, and this is derived from the product rule of differentiation. Recall, when we have two functions of x, u times v, we differentiate them. The derivative equals to u times the derivative of v, which is u dv, plus v times the derivative of u, which is v du. Now, by integrating both sides, we have the integral of the derivative of the product, that is the integral of u times v prime, equals the integral of u dv plus the integral of v du. Fundamental theorem of calculus tells us that the integral and the derivative on the left cancel, and we just end up with u times v, and that's equal to the integral of u dv plus the integral of v du. And then solving this for the integral of u dv, we have the integral of u dv is u times v minus the integral of v du. This is the integration by parts formula. The idea is to let the difficult integral be the integral of u dv, then call part of what we're integrating u, the other part dv, find du, find v, express the difficult integral in terms of the right hand side, and hope that integral on the right is easier than the integral on the left, and finish the problem. So in our case, we have cosine of the integral of cosine of ln of x, and we'll be calling that the integral of u dv. We have to decide what is u and what is dv. We only have two choices. So we write this as the integral of cosine of ln of x times 1 dx. Our choices are u equals to cosine ln of x and dv equals 1 dx, or vice versa. Well, one of the choices is really not practical, because if dv is cosine of ln of x, then to go from dv to v, we have to find antiderivative, which what we're trying to do in the first place. So that is not an option, and the only option is to let u equal to cosine of ln of x and the dv equal to 1 dx. So du is going to be minus sine of ln of x times 1 over x dx, and v is x. Our integral now looks like this. The integral of cosine of ln of x is equal to u times v, that's x times cosine of ln of x, minus the integral of v du, which is x times negative sine ln of x 1 over x dx. So let's simplify this. So we have the integral of cosine ln of x equals to x cosine ln x, minus a minus is plus, x and 1 over x cancel, so this is the integral of sine of ln of x. Well, when we look at the integral on the right, it's not any easier than the integral on the left, and it seems like we're kind of stuck because the integration by parts has not accomplished its goal to make the integral on the right be easier than the integral on the left. Well, sometimes that doesn't happen. It doesn't mean that the procedure is wrong. Let's now try to solve the integral on the right by using integration by parts. So the integral of sine of ln of x, we're going to solve it by parts the same way. U is going to be sine ln x, and the dv will be 1 dx. So du is cosine ln x times 1 over x dx, and v is x. So the integral of sine ln x by parts can be expressed as x times the sine of ln x minus the integral of cosine ln x after simplification. Well, again, looks like we're digging a deeper hole, but the solution is almost there. So let's go back to the original integral. The original integral was integral of cosine ln x. First iteration of integration by parts yielded the following: x times cosine ln x plus the integral of sine of ln x. We then performed integration by parts on this integral and came up with the following. So we have x cosine ln x plus x sine of ln x minus the integral of cosine of ln of x. Let's put everything together and get rid of the middle part. So the original integral of cosine of ln of x is equal to x times cosine of ln of x plus x times the sine of ln of x minus the integral of cosine of ln of x. When we look at this, it doesn't seem like we got anywhere, because on the left side we have the integral we're trying to evaluate, and then on the right we have the very same integral. Seems like we came full circle and got nowhere, but the solution is kind of staring at us right here. You notice that this is a minus sign, so if I take the integral on the right with a minus sign and move it over to the left hand side, the minus will be a plus. It's really adding two identical integrals. So now the left hand side is 2 times the integral cosine of ln x, and notice on the right we don't have any integration left, so it's just x cosine of ln of x plus x times the sine of ln of x. Divide by 2 and we have arrived at the solution. We found the antiderivative we're looking for. The integral of cosine of ln of x is equal to 1/2 x cosine of ln of x plus 1/2 x times the sine of ln of x. We can add a constant of integration c, and that's the solution. So this is an indirect way of solving it, but nevertheless it works perfectly. For more videos, visit www.mathprepvideos.com.